Hello, I'm Jorgen Miller, and this is my video for 351 final project. Here is my oscillating fan blowing over different thermistors which read the temperature and tell the fan whether it should slow down at their position and cool them off. I will show individual parts at a time. First, the fan speed. The fan speed is shown here in processing from 0 to 100. It is controlled by this potentiometer here. When it is turned and the fan speed decreases to about 50%, the fan slows down. This is accomplished using power width modulation. Using a tissue here, you can see it's not blowing very quickly. If I turn the fan speed up to 100%, the tissue is now blown much farther. Next, the fan is mounted on a servo. The servo is controlled by PWM signals as well. That makes it oscillate back and forth. In processing, the angle that the servo is rotated to is shown here. Currently, it is going between 45 degrees and 135 degrees. Finally, here are the 5 temperature readings gathered by the Arduino. There's one for room temperature and one's for other temperatures. On my physical circuit, the room temperature is here, and the other temperature sensors are all aligned here. All of these are measured by the Arduino and displayed in processing. If I warm my hand up over a warm drink and warm one of these sensors up, you can see it warming there. The angle has now will hesitate at that angle to cool the sensor off. Doing it again to warm up that sensor. The angle hesitates and the fan hesitates at that angle as well. I start warming it up now. The fan hesitates pointing at that sensor and will point at it until it cools it off and then moves on to the others. The physical circuit has several components. Here is shown the potentiometer and thermistors. These are all between the 5 volts and ground of the Arduino. The potentiometer is just read straight between 0 and 5 volts. The thermistors are all creating a voltage divider with a 10 kilo ohm resistor. This is because that is the nominal resistance of the thermistors. These are each measured by the analog pins, which can measure between 0 and 5 volts. Secondly, the mechanical actuation is controlled by external power source. This is the 4 AA batteries under here. This allows electrical isolation and reduces the noise caused by the actuation of these components. The fan is controlled by a transistor. The digital pin 3 goes through a 250 ohm resistor that I created out of a couple other resistors here. 100, 100, and 2 100s in parallel to make 100, 150. And that controls the fan. Looking at the fan specifications, it should have 200 milliamps of power. Thus, I chose 250 ohms to create 20 milliamps of power off of the 5 volt D3 pin. This is so that the transistor will be in saturation when 10 times the current is passing through it. Secondly, the servo is attached to the 6 volt rail and the 0 volt rail and is controlled with the PWM signals through the digital pin 2. Those are controlled in these wires here going to the servo. So those are all the components of my circuit here, and all of the relevant information is displayed in processing. Thank you.